Welcome to Adam. So now we are going to solve this question based on like IC engine, which has 6 cylinders, works on Otto cycle, and has a bore of 20 centimeter and a stroke of 40 centimeter. We have been given the clearance volume and we have been asked to calculate the compression ratio. So it is a very simple problem. So firstly, we will just write that the compression, like the clearance volume, is 9,000 centimeter cube, which is cubic centimeter. Same thing. So cc 9,000 cc is the clearance volume. And we know that the definition of compression ratio is nothing but, so this is small r, which is a compression ratio. The definition of compression ratio is nothing but the volume which was before the compression divided by volume which was after the compression. So the before the compression we have volume swept plus volume clearance as the volume, and after the compression we will just left with volume clearance. So what we mean by this is imagine a engine cylinder where we have TDC, we have BDC, and your piston is somewhere between fluctuating between TDC and BDC. So if you are on BDC and you are going up, like you are compressing the gas, so there will be some volume which is really V clearance where the piston will not go. There only combustion of the gases will happen. So that volume will remain always remain. So when you are at BDC, you have that volume plus this volume, which is nothing but a V swept, or we call it as V swept, which can be defined at pi by 4 into d square into L from the cylindrical volume formula, where d you have as a bore. This is also called as bore, which is nothing but the piston diameter. And L is nothing but a stroke length. So this volume is also called as the stroke volume, which we have between BDC and TDC. So that will be there. So this is the before the compression thing, where will be the stroke volume, also the clearance volume. But after the compression, you will be at TDC, only clearance volume will remain, not the swept volume, because you will be covering the swept volume by the motion, right? Throughout the motion, you will be reducing the swept volume and going to TDC, and only the VC will remain, like the clearance volume will remain. So this is how you can derive the compression ratio in the terms of swept volume and clearance volume. So you can say that we have been given the clearance volume for 6 cylinders, and we need to find the swept volume only now. We have pi by 4 into d square. D is nothing but bore again. So it has a bore of 20 centimeter as given in the question, into L as 40. We have pi divided by 4 into 20 into 20 into 40. We have 12,566 cc as the stroke volume. But this is only for one cylinder. As you can see here in the diagram, this is only for one cylinder. But we have been given that engine has 6 cylinders. So we need to multiply this into 6. So into 6, we will have the total volume as 75,398.22 cc. So this is our total swept volume, and VC not VS. So the compression ratio will become this VS plus the VC, which we have as 9,000, divided by 9,000 again. So it will be plus 7,000 divided by 9.37 will become your compression ratio. As you can see, you can calculate the using the VS and VC. In this question, the main thing was calculating the VS and knowing the formula of compression ratio in the terms of VS and VC, which is clearance volume and the swept volume. So this is how you can solve this very simple question. Thank you.